A neuron itself is just a function, one that can take any number of inputs and has one output. Each input is multiplied by a weight, and all are added together along with a bias. The weights and bias make up the parameters of this neuron, values that can change as the network learns. We'll simplify this down to a two-dimensional function, with only one input and one output. Now, neurons are our building blocks of the larger network, building blocks that can be stretched and squeezed and shifted around, and ultimately work with other blocks to construct something larger than themselves. The neuron is actually an extremely simple linear function, one which forms a flat line, or plane when there's more than one input. With the two parameters, the weight and bias, we can stretch and squeeze and move our function up and down and left and right. Turns out, linear functions can only combine to make one linear function. This is a big problem, because we need to make something more complicated than just a line. We need something that is not linear. In our case, we will be using a ReLU, a rectified linear unit. Well, let's give it a shot anyway, and see if it performs any better than our previous attempt. We're still trying to approximate the same function, and we're using the same weights and biases as before, but this time we're using a ReLU as our activation function. And just like that, the approximation looks way better. Unlike before, our function cannot simplify down to a flat linear function.